Saxon Advanced Mathematics, Lesson 63, Circles. You know what? I get annoyed with circles. Back in the old, easier levels of geometry when we were like calculating the area and the circumference, that pi throws everything off and I find it somewhat annoying. But this kind of circles, where we're studying the equations of the circle, I find much more interesting and fun. And if you're not convinced, maybe this lesson will convince you, or maybe you'll just hate it even more. I don't know. Let's recap what we know. Here is a cute little circle. No, I haven't drawn the circle yet. Sorry, what am I saying? I'm going to draw the circle. The center of the circle is at point 2, 4. It's right there. The radius of the circle is 3, which means I can go 3 units this way, 3 units this way, 3 units this way, and this is going to get up into the words, but there, 3 units this way. And by measuring the radius out in every direction, I can pretty accurately draw the circle. You may take objection to that. My radius is 3, 1, 2, 3. I drew this point too far. That's part of the problem. The radius equals 3, and the center is 0.24. Now, the equation of a circle in its standard form looks somewhat hideous when I just write it out. That's an H. That looks terrifying, but if I plug in the numbers, it's much friendlier looking. X minus 2 plus y minus 4 equals 3 squared. Okay, so this helps me graph it, right? This is the x coordinate of the center, this is the y coordinate of the center, and this is the radius squared. Okay, cool. So this is really great when we want to graph it, and we call that the standard form. And then what we learned is that you can multiply it, right? If we square both of these binomials, just like, let me just write multiplied. We're going to square both of these binomials. It's x squared minus 4x plus 4, right? That's that much. And then I'll square this one in my head, plus y squared minus 8y plus 16 equals 9, right? I just multiplied out the binomials, and then I can rearrange this by pulling everything this way and simplifying like terms, and I'm going to change my order just a bit. I'm going to do the x squared and then the y squared, and then the x and the y term, so minus 4x minus 8y, and then all three numbers I can smush together. That's 20, and then it'll be minus 9. So I combine all three of the plain numbers into a single value, and I keep it on the left side of the equation. So this is what we call the general form. Okay? And all we did was we just multiplied out these binomials and rearranged it. Okay? Rearranged. I want to write that. So now what we're going to do is we're going to be given the general form, and we have to put it into standard form. So we're going to go in the opposite direction in this lesson. And in order to do that, you'll never guess what set of steps we're going to use. Completing the square. Oh my gosh. Aren't we lucky? So let's try one. Example 63.1. My Algebra 2 students are ready to just, I was going to say punch a baby, which is kind of a rough expression, but they have had it with completing the square. They're so over it and so sick of it, and I don't have the nerve to tell them how often it's going to come back in the next year to get them. So don't tell the Algebra 2 students about completing the square. Okay, the equation, big fat ugly thing, is the equation of a circle. Complete the square to change this equation to the standard form and then graph it. Okay, so now I'm ready to show you what it is. X squared plus y squared minus 6x. Sorry, I hate when I do that. Okay. Wow. We have to turn this into two perfect squares. So what we're going to do is we're going to have the x squared and the x term and room to add a perfect square. And then over here we'll do the y's. And this is plus 8y. I want to make sure I copied that right. Yes, this is plus 8y. And then we have to move the 21 over. So that becomes minus 21. Okay? So now we have kicked the plain number to the curb. We've arranged these so the matching letters are in their own happy little clubhouses. And now we have to calculate two magic numbers and then add them to both sides. So for the x magic number, here come my magic numbers. For x, it's going to be minus 6 divided by 2, right? If we have a fraction, we multiply by 1/2. But if we have a whole number, we divide by 2. We're going to square it, add that. So this is going to be 36. Well, we can reduce this. I squared it as a fraction, but that's the harder way to do it. Let's reduce this first. It's -3. -3 squared is positive 9. Okay? So then I add the positive 9 over here. Now for y, we have to do another magic number. That is 8 divided by 2 quantity squared. That's 4. So that's 16 is my magic number. And then I have to add 16 over there as well. All right? Now we're ready to collapse both of these. The first one, and again, I can use my arrow pointing into my magic number calculation to help me. This will be x minus 3 quantity squared plus y plus 4 quantity squared. Use these calculations to help you find those numbers. Minus 21, and then this is plus 25, I see, so this equals 4. Or I can write this as 2 squared, because that's the form that I want it in. Now, it's going to be super easy to make my circle, because I know that the circle is centered at the point positive 3, negative 4, and I know the radius is 2, right? Okay, and so now all we have to do is draw a happy picture. That's going to be more or less in the 4th quadrant. So let's see, well, I'll make a handful because I have to mark off the radius as well. Okay, so first I do the center, 3, -4, 1, 2, 3, 4. And then the radius is 2. So I just mark 2 units in every direction, right? So I go up 2 units, to the left 2 units, to the right 2 units, and down 2 units. That marks my radius in enough places that I can draw a decent picture. And then if I want to be super fancy, I label this. I'm going to label this as plus 3 minus 4. And then I'm going to draw in a radius anywhere, and I'm going to write r equals 2. This is the glory of my answer. It's the right answer. Yay. Okay, so this is us going from general form to standard form, which is the graphable version, and then graphing it. Should we do another one? There are 2 more. 63.2. I hope you will agree with me. These aren't hideous. And we've done enough completing the squares that it kind of fits in our brains, right? Kind of. All right, 2, given the general form of a circle, complete the square to write the standard form and then graph. Okay, same instructions. So here we go. I'm writing it directly as it comes out of the book, but I'm going to give you a tidbit. Double check for accuracy. Okay, this is how it's written in the book. If you want, you can skip writing it as is and go right to going, okay, there's going to be an x perfect square, and there's going to be a y perfect square, and then there's going to be numbers over here. And then I know it's x squared plus 4x, and it's y squared minus 6y, and I'm going to bump the minus 6 over here. If you want, you can copy it out of the book this way. That's kind of a pro tip, honestly. I think that in the beginning, it's better to write this so that you have it all in front of you and you can kind of go step by step. But as you get more experience, if you want to take these out of the book and not bother to write that, I think that's okay. Magic number time for the x's. Remember, we always take the b value, which is 4, we divide it by 2, we square it, and we draw an arrow to the inside of the parentheses. That's going to help us. 4 divided by 2 is 2. If you're at all unconfident in your completing the square skills, this just gives you another chance to practice. For the y's, we take minus 6, we divide it by 2, we draw an arrow, put the parentheses, square it. Minus 6 divided by 2 is negative 3, so it's plus 9. All right, we just added a 4 and a 9, so we better add a 13, right? This and this are balanced by that. All right, now we're ready to write the perfect squares. Remember, these numbers will help us. X plus 2 plus y minus 3 equals 7. Now, 7's not a perfect square, so how are we going to find the radius if that's not a perfect square? Ready for the hack? We take the square root of 7 and square it. So the radius will be the square root of 7, because when we square it, we get 7. Isn't that like a weird kind of mind-bendery mini hack? Okay, we're ready to graph. Let's write down our information. The center, remember in the basic formula, these are minus signs. So this center will be minus 2, positive 3. We have that old take the opposite sign gig happening. And the radius is the square root of 7, which is going to be, let's see, it's somewhere, it's less than 9, right? It's between square root of 4 and square root of 9. So it's going to be 2 point something. We know it's not as big as 3 because the square root of 9 is 3. Square root of 4 is 2. So it's somewhere between 2 and 3. All right, so here comes our picture. I'm just going to draw the whole thing this time. Negative 2, 3. So my center is here. Square root of 7, I'm just going to, and it's between 2 and 3, so I'm just going to kind of bluff it this time. I'm going to make it 2 plus a little. And then I'm just going to draw a nice circle. And then I'm going to label it. My center is minus 2, positive 3, and my radius equals the square root of 7. Yay! We could take a calculator if we wanted, and we could find the exact value of the square root of 7, but we know it's between 2 and 3, and that's good enough for pictures, for the purpose of our pictures. All right, one more. Similar, just a weensy bit, I don't want to say harder, just a little more insane. I mean, as if these other problems aren't insane enough. 63.3. Given the general form, blah, 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 complete the square to write the standard form of the equation and describe the circle. Describe the circle. That means we don't have to graph it, we just write center and radius. So that's good, he's given us a little break on this one, but when you see the equation, you'll see why. Yeah, there's a 2 on that. Oh, there's a 2 on that as well. Isn't that jolly? Okay, so what this means, in order to complete the square, we can't have coefficients on our squared terms. So, thankfully they're the same coefficient. We have to divide everything by 2. Can you just imagine? So now these cancel, but now we have drama over here. So now our equation looks like x squared plus y squared minus 1/2 x plus 1/2 y. And let's just kick this for now. It's going over there anyway. And we'll move the 3/2 over there. All right, now let's set these up in their own happy parenthesis families. So we'll have the x squared, and then we'll have minus 1/2 x. Whoops, I can make that bigger. And then we'll have y squared plus 1/2 y. We're going to squeeze in one more number. Magic number calculations. Okay, remember that when our b value is a fraction, it helps if instead of dividing by 2, we multiply by 1/2. Same difference, it's just a little bit easier to calculate neatly. All right, so this is going to become 1/4, and then when we square it, we're adding 1/16. Oh, good Lord. This is 3/2, and we're now adding 1/16. And then let's do the same calculation for the y's. It's plus 1/2 times 1/2, because that's the formula, right? Divide by 2 or multiply by 1/2, same difference. This is 1/4. When we square it, this is also plus 1/16. So we have to add another 1/16, right? This is for the x's, this is for the y's. All right, well, that's real cute. Looks like we're gonna have to change this so that it has a denominator of 16. So let's see, we'll have to multiply it by 8/8, right? So this becomes 24/16. Cross that out. All right, now I can write my perfect squares, and I'm gonna use these arrowy numbers here, look. That's fancy, right? I just made the arrow point up and down. We're gonna use those values when we make our perfect squares. Ready? X minus 1/4, quantity squared, plus y plus 1/4, quantity squared, equals, now we have to add all these up. This is 24, 25, 26. 26/16. And we have to find the square root of this because we want to write it as a square. So we're going to write 26 square root over 4. This I'm leaving all the same. I'm just copying it. And so this squared equals that, right? 26/16. Square root of 26 squared is 26. 4 squared is 16. Okay, so this is the correct value for the root because we want to square it. That tells us that our center is at positive 1/4, negative 1/4, right? Because the signs are in opposite land. And the radius equals the square root of 26/4. And this is approximately equal to, we can just eyeball that. Square root of 25 would be 5. So this is roughly 5/4. So it's about 1 1/4 units away from this. This would be hard to graph because fractions, fractions, fractions. So we're not going to graph it, but John just wants us to give him this information that our circle has a center here and a radius here. Let me double check. 1/4 minus, yep, this is the right answer. Okay, so at least it's nice of John when he makes the numbers obnoxious, he at least tells us we don't have to graph. We could if we wanted, but we don't have to. Yay! Guess what? We're done with lesson 63. I hope you agree that's more fun than multiplying anything by pi. And so I have no complaints. Thank you. Goodbye.